Okay, hello, good evening. Welcome back to our August week 4. Okay, so good evening. Just saying hello. There's only you to I don't think so lah. You are the earliest today. Alright, that's all I can say. Alright, so if you have seen my Google Classroom announcement, we are going to enter a new chapter today. Okay, we are going to enter chapter 13 today. All right, because chapter 12 we already finished last week, which is the sound one. Okay, we have finished all these already. So, oh yeah, we still haven't, there's still some exercise I haven't do, huh? Okay, let me give the answer for this. Okay, let me finish discussing this first, and we shall enter chapter 13. All right, so number 6, the figures are the 4 traces of sound wave on the screen of an oscilloscope. Oscilloscope is the meter. It was a meter, the screen that looks like this. This is the oscilloscope. So you can see 4 waves here. So which sound has the greatest amplitude? Amplitude is the height. Okay, that's the volume of the sound. That will be your C. Okay, so out of all, C is the highest. Which sound has the smallest frequency? Smallest frequency means the furthest away. That would be your A. Right? Frequency means very close. Smallest frequency means they're very far. So which sound is the softest? Softest means smallest amplitude. That would be your D. And then highest pitch, that means the highest frequency. Highest frequency would be D as well. Right, would be D as well. Okay, so like I said, frequency will determine your pitch. Amplitude will determine your volume. So that's the difference. Okay, so number 7, complete the tables below to show how we can change the pitch and loudness of a drum and a guitar. So if the drum is very tightened, okay, the thing is very tight, so your pitch will be high. Okay, both will be high, but loudness depends on how hard you hit it. If you hit it soft, then the loudness is soft or low. Right, if you hit it hard, then the loudness is high. All right, so this is the amplitude, and this is the frequency. Okay, so loosen, when it's loose, then the pitch is low pitch, as in dong dong. Okay, if you stretch it tight, it's dong dong, higher pitch. So soft and hard is the same thing. You have low and high. All right, so this column determines this, and this column determines this. All right, easy. So same goes to our guitar. It's the same answer here. So if the string is very short, this thing will vibrate very fast. So it will be high pitch. Okay, high pitch. So if you play guitar, you know lah. You press it here, the pitch is very high. If you press it here, then the pitch is very low because the string is very long here. So it vibrates slower. So loudness, if I strum it hard, like tang like that, so the volume will be high loudness. If I play it soft, then the loudness will be low. And then long string, same thing, it will be low pitch. And if it's hard, it will be high loudness. Soft will be low loudness. Okay, so easy, huh? So the pitch has nothing to do with the volume, they are separated things. One depends on the frequency, one depends on the amplitude. Okay, so next, what are the changes that can be observed if a guitar string is tightened? Okay, if a string is tightened, the string becomes tighter, so they vibrate faster. So the frequency will increase, or you can say the pitch becomes higher. The pitch is higher. Okay, so it's like tuning your guitar, like, like if you tighten it, then the pitch will become, higher. So a guitar string is plucked harder, then it will be louder. All right, it will be louder. It should be easy, huh? This one. I hope you understand, huh? So the figure below shows a string musical instrument. Okay, this is a guitar. The string is plucked at X to produce a sound. Okay, this is how you strum. At which point should the string be pressed to produce a sound at the highest pitch? So same answer will be your R. If you press it here, the string vibrate very quickly, whereas you press it here, the string vibrate very slowly. So the highest pitch is here. So explain your answer. So you can say the string vibrates at the highest frequency. Okay, the highest frequency. Bergetar pada. Oh wait, what am I writing in? Sorry, because I was writing in Malay just now. Okay, sorry, brain fart. Okay, I've been writing Malay for the whole day. So that's why my brain is thinking Malay mode right now. Okay, anyway, so the string vibrates at the highest frequency, so you have the highest pitch. Okay, so these are all for our exercise. Okay, this is our sound chapter. I hope you got all of it. All right, so for those who are late, we cannot wait for them. All right, anyway, let's go to our chapter 13 today, shall we? Let's move on to chapter 13. This is also a very interesting chapter. Have you learned this in school? Okay, Jason, have you learned this in school? There's only you today. Okay, okay, Wei Jun is not here today. Charlene is not here today. What's with everyone? Okay, everyone's not here today. Right, anyway, so without further ado let's go to question 13 Maybe you have learned this in your school already. Okay, I hope you have. I mean, if you have learned it, then it's okay. All right, anyway, let's move on. Okay, I'm gonna. Oh no, that's not someone coming in. Okay, so let's move on to chapter 13. All right, so last week we learned sound. This week we will learn light. All right, so it's a more or less a similar concept. All right, and I think in September, we will be finishing our syllabus already. We are definitely ahead of schedule. Okay, and we shall do some revision, you know, in September. All right, so let's begin our chapter 13 All right, so let's look at light. Okay, what is light? Okay, as you know, light is light. All right, but in terms of physics, what is light? Light is actually something what we call an electromagnetic wave. Okay, in short, we call it an EM wave lah. Okay, an EM wave. So you might be thinking, okay, so what is this? What does it even mean? What is electromagnetic wave? Electromagnetic wave is a type of wave produced by atoms when they vibrate. All right, when atoms vibrate very quickly, they will produce a special type of wave called electromagnetic wave. All right, so this is the spectrum of electromagnetic wave. Now, what does it mean by a spectrum? Electromagnetic wave has many types. It's just like color. You see, color has red, orange, yellow, green, blue, indigo, violet. So we have like the spectrum of color. All right, so it's the same thing. So it's just like your radio lah. Okay, your radio. When you're playing with your radio, let's say you're tuning your radio in your car, it goes from 88 point something all the way to 110 point something, right? And then different radio station, you know, different number, you hear different radio station. So this is what we call an electromagnetic wave. So it is a you know, a spectrum of wave. All right, so it is a form of energy. So as we know, wave is an energy. Ocean wave is an energy, right? Sound wave is an energy. Last chapter we learned sound, right? Sound is a wave. Sound is an energy. All right, so this is today another form of wave, which is your electromagnetic wave. All right, so you might say, okay, so what is this? What the hell is this? Okay, so electromagnetic wave has many types. In fact, it has 7. All right, so you have 7 types of wave here. Okay, so the first one, okay, let's not care about this extremely low frequency. This thing has no use. We don't use this. All right, so what's the first type? The first type is what we call radio wave. All right, radio wave. So what is radio wave? I'm sure you know what is radio wave lah. Okay, before you think, okay, radio wave means radio. Many people will think this, okay, radio wave means the radio in your car. No. Radio wave has many types. Your TV uses radio wave as well. All right. Your remote control, okay, remote control they use infrared. Okay, I'll talk about that later. Your Bluetooth, your Wi-Fi is radio wave. Okay, the signal on your phone. Okay, you know your phone has signal, right? Okay, the full bar signal. Sometimes if you're at if you're in city, your signal is like 4 bar. That's the radio wave as well. When you call someone, that's radio wave. Wi-Fi is radio wave. Right, so all the not just the radio in your car is radio wave, as long as you are using it for telecommunication. Right, telecommunication, Wi-Fi, we use it for telecommunication. So anything we use for telecommunication, we call it a radio wave. So that's the difference. All right, so this is your radio wave. This is the first type of electromagnetic wave. So that's the first type. You cannot see radio wave. All right, you cannot see radio wave. And of course, the next one, which is your microwave. All right, before you think, oh, microwave is that oven, right? Okay, that is a microwave oven. Okay, microwave has many other uses. Microwave is mostly used by military communication. Okay, military communication. That means if you are in the military, they don't communicate using radio wave because this is easy to hack. Okay, this is easy to hack. So because military is supposed to be classified, it's supposed to be secret, so they will use microwave. All right, not much to talk about this because we don't really use microwave unless it's an oven. And of course, your infrared. What is infrared? This is the ray, this is the electromagnetic wave that gives you heat. Okay, heat. When you put your skin under the sun, okay, let's say you stand under the sun, you can feel that heat from the sun. That's the radio wave, that's the infrared. It's the similar feeling of you sitting next to a heater, right? Let's say you sit beside a heater or a fridge. Okay, the behind of a fridge has heat, right? So if you sit beside a heater, the heat you feel, that's infrared. Same goes to your sun. So your sun will produce infrared. So I'm sure you know this thing. Okay, hang on. I'm sure you know this thing. What is a thermometer? What is an infrared thermometer? They use the infrared to scan your forehead. I mean, don't tell me you don't know this. Okay, so we've been using this for so many years. These 2 years anyway. So this is the thermometer that uses infrared to tell you how hot you are, because infrared is all about heating. All right, infrared is all about heating. So there you go. There you go. So your infrared, we use it. Anything to do with heating is infrared. Okay, your sun, like I said. Okay. When you go and tint your car window, this one you go and ask your dad. When your dad tints his car, you know what's tinting? You know what's tinting? Malaysia is very hot, right? So when you buy a new car, you have to put that window tint on your car window. So that your car window is actually tinted. And the more money you spend on a tint, the better they can prevent the infrared. That means they can make your car cooler lah. That's the infrared. All right, so that's your infrared you use. Oh yeah, your remote control also uses infrared. I know your remote control is not supposed to heat you up, but they use infrared. All right, and of course next is your visible light. This is what we are focusing on this chapter. Visible light is just one of the type of electromagnetic wave. Okay, so EM wave are all these all those waves that I talked about just now. They are all EM wave. Visible light is another type. Okay, hang on. Yes, Rijun, hello. Good evening. Okay, you are late. All right, so we are in chapter 13. We're in chapter 13. So if you are in my Google Classroom, I already posted there. We are using chapter 13 today. Okay, you are supposed to receive this next week, but okay, since we finished our August syllabus early, so we will go into a new, we will go to a new chapter. All right, so anyway, so we were talking about light. We finished our last chapter. So let me repeat again. Radio wave, okay, electromagnetic wave has 7 types. Okay, so your radio wave, this is for communication. Microwave is for oven. Infrared is for temperature. Visible light is the only EM wave that you can see. All these other waves, you cannot see them. Not with our eyes at least, okay? Other animals, maybe they can see them, but we cannot see them. So visible light is the only EM wave, electromagnetic wave, that we can see. So that's your EM wave. All right. So your visible light, if you still remember, your visible light has 7 colors. All right. This is the basic of rainbow. So blue, indigo, blue, orange, yellow, green. Red, orange, yellow, green, blue, indigo, violet. That's your visible light. And then of course, guys, can you see there's a line here? Can you see there's a line here? This part is blue, this part is yellow. What does it mean by non-ionizing? Okay, non-ionizing means they are not dangerous. So far, these 4 types of radiation we are learning so far, they are non-ionizing. Okay, guys, when we say radiation, okay, have you heard this word from your mom? She will always say, "Ooh, radiation is bad. Radiation is bad for you. Your phone has radiation. Your Wi-Fi has radiation." Have you heard that before? Okay, they say this thing supposed to give you cancer lah. Okay, you shouldn't use things with radiation lah. All right, so radiation. Okay, you might say, "Sir, what is radiation?" Radiation is radio electromagnetic wave. Okay, EM wave is radiation. So you can see that radio wave is a radiation, microwave is a radiation, infrared is a radiation, and visible light is a radiation too. Right? So do you get cancer from radio wave? No, you don't. These 4 radiation, they are non-ionizing. These 4 types of wave, they are non-ionizing. Non-ionizing means they won't harm your body. Okay? You don't get cancer by radio wave. So talking on a phone, using Wi-Fi, using Bluetooth, they don't give you cancer. All right? Stop being lied to. It's just a stupid way people saying that, oh, this thing gives you cancer. Come on lah, there are much more dangerous things that gives you cancer. Radio wave doesn't give you cancer. Microwave doesn't give you cancer. Infrared doesn't give you cancer. Visible light doesn't give you cancer. Just because you switch on your light, you get cancer from your light. No, okay, that's just ridiculous. All right, going down, that is when things starts to get dangerous. These are ionizing. That means they are dangerous EM wave, dangerous electromagnetic wave. They can harm your body. For example, number 1, ultraviolet. You know what is ultraviolet? You know what is ultraviolet? Ultraviolet is your UV ray. Yes, Jaden, hello. Good evening. Are you using a different account today? Why is your name different today? Okay, welcome. You are late. Okay, you don't know, huh? Okay. Anyway, have you seen my Google Classroom? Have you seen the Google Classroom? We are going to chapter 13 today, huh? We're going to chapter 13 today, huh? Okay, anyway, we were just talking about wave, huh? All right, so let's talk about ionizing radiation. Ionizing electromagnetic wave, okay? These are the dangerous types of radiation, so-called. All right, so number 1, UV. Do you know what is UV? UV is the thing in your sunlight. You know, when you stand under the sun for a period of time, your skin gets dark, right? That's the UV. All right? The thing that turns your skin dark, that's the UV ray. So guys, UV ray is an ionizing radiation. This thing will for sure give you cancer. Next, X-ray. Okay, X-ray. The lower you go, the dangerous they are. So X-ray is even more dangerous. I mean, you know this, right? Do you simply go and get an X-ray for no reason? No, you don't. Right? You don't simply, oh, you know what? Today I want to go get X-ray for no reason. No, you don't do that unless you suspect that you have some kind of injury, then you go for X-ray. Right? So because X-ray is radiation. This is why pregnant women, okay, if you are pregnant, if you are a woman, you are pregnant, you want to see your baby, you go for ultrasound. You don't go for X-ray. You don't scan your baby using X-ray because the radiation is going to harm the baby. All right, so that's your X-ray. And then the last one, the most dangerous would be your gamma ray. What is gamma ray? This thing is produced by radioactive substances. You know what is radioactive? You know atom bomb? you know, nuclear reactor, when they explode, this is what they produce. This is the most dangerous electromagnetic wave because they will for sure, absolutely 100% give you cancer. All right, so the lower you go, the more dangerous they are. So if you compare these three to radio wave, now it just sounds silly, isn't it? All right, when they say, oh, don't talk so much on your phone will give you cancer. Oh, I even heard my friend told me, hey, bro, you know, you should turn off your modem at night. So I was like, huh? Why do I need to turn off my modem? Oh, because that thing will give you cancer. So I was like, really, bro? You know, stupid can that thing won't give you cancer. All right, you see, people are very funny, okay? They just like to think that they're very smart. They think Wi-Fi will give them cancer. You see, ultraviolet will definitely give you cancer. Do you see people putting on sunscreen? Okay, you see how stupid this is? You see how stupid this is? Okay, all the boomers okay, our parents okay, the boomers generation, they like to say this one, oh yo, don't use handphone. Okay, last time my mom used to say it, okay, why are you on your phone all the time? This thing will give you cancer. You know who uses the most phone now? It's her. Right? You see, our parents very funny one. They told us not to use phone. They are the one that use the most. Right? Right? Because my mom is like that. Right? Anyway, so phone, they are radio wave. They won't give you cancer, but your sunlight will definitely give you cancer. So please put on your sunscreen. Like seriously, okay? If you are marching in your school, okay, you are doing any activity under the sun, please, for the love of God, put sunscreen. That thing will give you skin cancer. Scientifically proven. X-ray, this one, don't get it without reason. Gamma ray, I don't think you have the chance to see gamma ray. Okay, only like two situations you can see gamma ray. Number one is from an atom bomb, okay, or from nuclear reactor. Second is during radiotherapy. Do you know what is radiotherapy? If you got cancer, right? You go for this therapy, they will use laser, so-called laser to kill your tumor. In Mandarin we call it 电疗，就是他拿 laser 去射你的肿瘤so that thing is gamma ray So only that we only use gamma ray for that. Because gamma ray will for sure kill cancer cell. We use gamma ray to help us kill cancer. So these three, they are pretty goddamn dangerous. Okay, so your light you see like I said the more right side you go the more dangerous it becomes. So to be fair, light is actually more dangerous than radio. That means switching on your light in your room is actually more dangerous than talking on the phone or using Wi-Fi. So do you see people say, oh, don't use so much light, light will give you cancer. You see how stupid that is? So no, these four, they won't give you cancer, but these three, they will give you cancer. So try to avoid them as much as you can because they are ionizing radiation, ionizing electromagnetic wave. Okay, so for those who just came in, Wei Jun and Jaden, what is electromagnetic wave? Electromagnetic wave is a wave produced by atoms when they vibrate. Okay, when an atom vibrate, they will produce electromagnetic wave. All right, so the only wave that we are focusing on this chapter would be our visible light. We are only focusing on light for our chapter, this chapter, right? So the other six okay, I'm just letting you know for fun, okay? You're just learning it for fun, all right? So this would be your light, okay? So light is a type of, as you can see, the first point here, light is an electromagnetic wave. So we have 7 types of electromagnetic wave. Light is just one of it. Okay, the only electromagnetic wave you can see. You cannot see radio wave, you cannot see microwave, you cannot see infra, ultra, X, or gamma ray. You can only see visible light. This is the only electromagnetic wave that you can see. All right, I've repeated many times already. So next, objects that emit light are described as luminous. Example, the sun. Our sun can produce their own light, so it's called luminous. Your light bulb is luminous. All right. objects that do not emit light, they are non-luminous. For example, the moon. Okay, the moon is not luminous. I think you know this. They just reflect light from the sun. Moon itself, they don't produce light. Okay, the moon you see is actually from the light from the sun. They just reflect to us. Okay, so anyway, we can see non-luminous object when they reflect light. All right, so why is it when you switch on light in your room, you can see everything? Because you see, when you switch on light, light will bounce off every object that will enter your eye. This is how you see something. Okay, you get what I mean? You get what I mean? When light hits any object, okay, any non-transparent object, you know it's transparent, like, right? Like glass. If light hits any non-transparent object, they bounce to our eye, then we can see the object. This is why when you walk into a dark room, let's say you walk into a dark room, you switch off all the lights, you don't see anything because there's no light bouncing into your eyes. You see black. No light means black. You see nothing. All right. So non-luminous object. Okay, let's say your table. Okay, your table is non-luminous, but when you switch on the light, they bounce light to your eye. They reflect light to your eye. That thing will be seen by you. Okay, so light travels in a straight line. As we know, this is how we make shadows, right? Light, they can only go straight. They cannot bend. Okay, so a transparent or translucent object allows light to pass through. What does it mean by transparent? Okay, what's the difference between transparent and translucent? All right, transparent means they allow light through like 100%. 100% light can pass through. That's transparent. Like glass is transparent. Like water is transparent. Okay, like see, all your glasses, they are transparent because light can pass through. So what is translucent? Translucent means the light can pass through half. Okay, some of the light, they are bent. So that's why you see this blurry image using a translucent, like your shower screen lah. Okay, like your shower, okay, not shower, okay, your frosted glass. Frosted glass. This is translucent. Okay, there. If you need some privacy in your office, you will put this thing. You see, translucent. That means you can still see. They're like half transparent. You can still see. You can still see what's behind the glass. It's just that they're kind of blurry. Because they just bend the light away. And of course, opaque. When they hit an opaque object, opaque means 100% cannot pass through. Okay, a shadow will be formed. Like wood, like your wall, they are opaque. It means light cannot go through. All right, easy, easy. So please make sure you know these three words. What is transparent, what is translucent, and what is opaque. The three words. Okay, so anyway, let's look at reflection. Okay, this is the first thing that we are going to learn first. That will be a reflection. Okay, I don't think we can finish color. Okay, let's talk about reflection. Okay, so what is reflection? Reflection is the bouncing of light. Simple. All right, when you look in a mirror, that is reflection. I'm sure you know this. All right, so what is reflection? An opaque object does not allow light to pass through. Instead, light bounces off it. So let's say this is mirror, right? This is mirror, right? So light cannot go through mirror because mirror is not transparent, but it will be bounced off. So when light bounce off, that is your reflection. All right, the bouncing of light away from an object is called reflection of light. So mirror is reflection lah. Okay, so when you see reflection, you will see this diagram. Okay, you will see this diagram. So can you see this line here? Okay, can you see this line here? I want you to take note of this line. All right, when light comes to an object, we always draw a straight line first. Okay, this line is 90 degrees to this line here. Okay, imagine this is a mirror. Imagine this is a mirror. We will draw 190-degree line here. So this line is called the normal. Why is it called normal? Don't ask me. Because normal actually means 90 degrees. Okay, so this is a normal line. All right, so why draw a normal line? Guys, this line doesn't exist. This line doesn't exist. This is a line just to help us imagine. This is a line to just help us imagine. So you see, when okay, what is an incident ray? Incident ray is the light coming in. All right, incident ray is the light coming in. So imagine there's a light coming in. when it hits the mirror, okay, when it hits the mirror, it will be reflected. So this line is called a reflected ray. That's the going out ray. In is incident, incident what? Okay, incident, so coming in, and then the bounce off one, we call it reflected ray. Okay, please learn their names, because in exam they will ask you to label which is incident, which is reflected. Just look at the arrow. Just look at the arrow. The going in one is incident, the going out one is reflected. So this one you know. Okay, can you see this normal line here? Can you see this normal line here? Why draw this normal line? Why draw this normal line? This is to help us look at the degree. Okay, this is to help us look at the degree. So can you see this degree here? Can you see this degree here? When we look at incident ray or reflected ray, we look at their angle. Why look at the angle? Because you see, all right, so first of all, this angle is called an angle of incidence. Because this line is incident ray, so this angle is the angle of incidence. So we measure from the normal, we don't measure from here. We measure from the normal. Always. Okay, so this is the angle of incidence. So when they bounce off, you create a reflected ray. So this is the angle of reflection. Can you see this purple color angle? This is the angle of reflection. So you might say, okay, so we look at the angle for what? Because you see, the law of reflection says, okay, please highlight this. Angle of incidence is always equal to angle of reflection. This is the law of reflection. It has to be obeyed, has to be followed. That means whatever angle of incidence is here, your angle of reflection will be the same. If I enter this angle at 60 degrees, I will come out at 60 degrees. For sure. If 40 incidence means 40 reflected, 45, 45, 60, 60. So always the same. This is what we call the law of reflection. Can you see now why I need to draw this normal line? Okay, so if I draw one normal line here, if you can find this angle here, then you will know this angle here. All right. Sometimes in exam, they will give you like that. Then they will ask you to draw here. This part will be empty. They ask you to draw here. So you just look at the angle. You just look at the angle. If the angle here is, let's say, 43.1, so you draw another 43.1 here. That would be your reflected ray. Okay, so let me repeat again. Angle of incidence, the going in angle, is always the same as the going out angle, the angle of reflection. So you will see two lines of the same angle for sure. Okay, and we don't measure it from here. Don't ask me why, but we just don't. Okay, we don't use this angle here. No, we don't. We measure it from the normal. This is why we draw the normal. You don't draw the normal. You don't draw the normal. You don't draw this line. You cannot draw this diagram. All right. So the law of reflection says angle of incidence is always equal to the angle of reflection. How much going in? That means how much going out. Okay, understand? Understand what I mean? Okay. So anyway, let's look at the next point. So wood and mirror are both opaque objects. All right. So imagine this is mirror. Imagine this is wood. So they are both opaque. What does it mean? That means they both don't allow light to go through. They both will reflect light, just like your mirror. All right. As I said just now, only opaque object, they will not allow light to pass through. They will always bounce off light. All right. So wood and mirror, they are both opaque. But why does the surface of wood look dull, but mirror looks shiny? Okay, why? Okay, maybe a better question. Why is it when you buy a new car, let's say you just buy a new car from a showroom, the car looks freaking shiny. Okay, the paint looks shiny. But after a few years of using it, let's say you don't take care of your car, you don't wash it often, you just park it under the sun for a few years, then you will start to realize the paint starts to become dull, not as shiny as the first day when you bought the car. Why? Why? Why is it like that? Why is mirror shiny, wood not shiny? Why is new car shiny, but old car not shiny? Okay, everything has to do with the surface. Okay, can you see? Can you see mirror has a very flat surface? That's the surface. So you see, a shiny object has a flat surface, as you can see here. Reflection of light rays are uniform. That means, can you see? The light will enter at the same angle, they will exit at the same angle. That means if this is 30 degrees in, 30 degrees out, 30 degrees in, 30 degrees out, 30 degrees in, 30 degrees out. So equally they bounce off. So when light, they travel in a uniform way, the object will look very shiny. Okay, you see? When they reflect in a very uniform way, they look shiny. They look good, right? It's like marching lah. It's like marching. If you see marching, they move their legs and feet at the same way, like this, you can see that uniform pattern and it looks nice. So same thing. When light moves in a uniform pattern, they look nice. That's why the surface will look shiny. So reflection of lights are uniform. All right, what about a dull object though? Okay, when an object is dull, okay, I mean, if you look at wood, you don't see the surface like this, but when you zoom in, you do. When you zoom into wood surface, they will just look kind of bumpy. They just look bumpy. So this bumpiness, they are not uniform. So the light will just simply bounce off. The light will just simply bounce. Okay, you see, this one no uniform, no pattern. So you don't see uniform light ray. So even though you see the reflection, it's not shiny. It's not a uniform light ray. So whereas a dull object has an uneven surface, bumpy surface, reflection of light rays are irregular. So you see, irregular bouncing. This is regular bouncing, so shiny. Irregular bouncing, so they look dull. Okay, dull. So can you see? Okay, let's say you spill a cup of water on wood. Okay, let's say this is your wood table. This is your wooden table. So if you accidentally spill a layer of water on it, so can you see your wooden table is actually shiny? When you actually spill water onto any surface, they will look shiny. Why? Because now the water is like uniform. The water acts like a mirror on top of the wood. That's why you have equal bouncing of light. So now this thing becomes shiny. But when the water dries up, okay, when the water dries up, now back to the dull surface again. You see now the light simply bounce off again like this. So you will see dull surface again, right? Guys, you get what I mean? You get what I mean? So even surface, flat surface, you have regular reflection, so it will look shiny. So uneven surface, bumpy surface, you have irregular bouncing, irregular reflection, so you have dull surface. All right, this is how your car works. All right, so when you first bought your car, I mean, if you buy a new car, okay, if you first bought your new car, your car paint looks like this. All right, because it just left the factory, right? Okay, you see, when the factory they paint your car, okay, when the factory they paint your car, they will put a layer of what we call a clear coat on your car. Okay, so what does it mean? Do you know what's a clear coat? Do you know what's a clear coat? So when you paint something, okay, when you paint something, you will spray a clear coat onto something to make them look shiny. Okay, for example, okay, we know that wood is uneven, right? So if you want to make a wood shiny, what do you do? What do you do? You put a clear coat on a wood, on a piece of wood. So if you put clear coat on a wood, now the wood will look shiny. Can you see? Can you see the wood look shiny now? So what are you doing? Basically, your wood looks like this, right? So when you put a layer of clear coat on it, you are basically putting a thin layer of something like a mirror on top of the wood. So now you have even reflection. So now the wood will look shiny. Okay, so same goes to your car paint. Same goes to your car paint. Of course, car paint, they don't use brush lah. They use the gun to spray. So they spray it on your car. So your car has that same clear coat. Some clear coat they are for wood. Your car has the clear coat too. That's why your car looks shiny. A new car will look very shiny because the clear coat is still very new. Right? The clear coat is a very new, like mirror level shine. That's why when you buy a new car from a showroom, let's say you just got your new car, the car looks, you know, shiny, okay, new, and it just looks nice, okay, because your light will reflect nicely the light, so your car looks shiny. Okay, as you start to use your car, okay, because you see your car is under constant harsh condition. You park your car under the sun, okay, you park your car under the tree has dirt. You drive your car on the road, road has dirt, it has stones that chip your car, all right? And then whatever lah, as you start using your car, and then there's rain inside. You know what is acid rain, right? I think you learned pollution, right? So acid rain, they also corrode your paint. So slowly, after a few years, if you don't wash your car, slowly, your car's clear coat will slowly become like this. They are becoming more and more dull. I mean, of course, it's not, you know, you don't see this in a few months lah, but you see this maybe in 1 or 2 years lah. The car will slowly become, you know, not as shiny as when you first bought it because of this clear coat becoming worse, right? Becoming worse and worse and worse. So what do you do? So what do you do? Now, when your car is dull, when you go to a car wash, what they will ask you to do? They will ask you to polish your car. Right? Have you heard of what is a car polish? When you polish a car, okay, car polish, if you take car polish is like a cream, and when you rub it between your fingers, it feels rough, like gritty and sandy. Just like your toothpaste. Do you know toothpaste is the same way? When you brush your teeth, that small gritty stuff like sand, they will clean your teeth. So same thing here. So if you polish your car, if you rub the polish onto your car, basically you are using that sand, that grit to cut a very thin layer of your paint. You see, imagine, okay, this is your car clear coat, new car. After a few years, your clear coat starts to become like this. Okay, starts to become like this. So what do? You polish, you rub a layer of polish, you slowly rub them back to like that. Rub them back to the flat surface. Okay, so this is why after polishing your car looks new again. Okay, because you are removing the top layer away so that they look nice and flat again. But then again, you cannot polish your car too many times. All right, you cannot say polish your car once every year and you polish it for 10 years. No, because the more you polish your car, the more clear coat you are removing. And if you keep removing those clear coats, someday you will get into the paint, which is bad news. Okay, because when you start polishing your car, let's say your car is red color, when you polish your car, you don't see red on your cloth because that's the clear coat. But if you polish too much, when you polish too much, you start to see red paint on your cloth. You're like, oh shit, you've gone too far because you already finished rubbing all the clear coat, right? Clear coat is not very thick, guys. Clear coat is not very. Your car clear coat from the factory is not very thick. That's why you don't simply polish your car. You don't say, oh, every Chinese New Year I just bring my car to the car wash and just ask them to polish. No, you polish maybe once every 3 years, 4 years when the car gets dull. You don't even need to polish if you know your car is in good condition. So this is why, guys, after you polish your car, okay, I mean, I love my car, okay, so after you polish your car, how do you protect this layer so that they don't get dull again? That's why you put a layer of wax. You put a layer of wax. Do you know what is waxing your car? I mean, you go to any car wash, you will see these two words, polishing and waxing. It's two different things. Polishing is to make your car shiny again. Waxing is to protect your car. All right. If your car already look like shit, okay, 5 years you don't wash it, okay, you are just lazy. 5 years of neglecting your car is a very dull now. There's no use for you to wax. Because there's nothing to protect. Your car is already so bad in shape. Your car already look like shit. You want to protect this for what? So in this case, you need to polish. You remove the outer layer first, and then you protect by putting wax. If your car is still in awesome condition, the paint is awesome, shiny, okay, then you need to wax your car once every, I don't know, few weeks, okay. So it depends on your wax lah. It depends on the wax lah. The wax will last. I mean, in Malaysia, whether they will last around 1 month. Okay, so every month, okay, you can wax maybe 2 months lah. So you wax your cars because this wax will be slowly eaten away by the rain. So there's no more wax, right? So now you need to apply one more layer, so they are protected again. Okay, you get what I mean? So as long as you keep waxing your car, okay, your surface will stay nice and even. So you will always, maybe even your car is like 5 years, 10 years already, your car is still very shiny because you take good care of your car. I mean, most Malaysians we don't lah. Most Malaysians we don't. That's why it's very seldom you see a very shiny car on the road. Okay, because taking care of a car is a very big commitment. You need to wash it all the time. You need to, I mean, have you guys waxed your own car before? If you have done that before, if your dad has done that before, by using his hand, you know how tiring this is. Guys, waxing your car is a very good exercise. It will take you easily 2 to 3 hours. And after you finish waxing your car, your back will hurt like hell because it's so sore. Right? So if you don't, okay, guys, if you drive a Myvi, nothing wrong with Myvi lah. But if you drive a Myvi, normally people don't care. Okay, so you just simply lah, you go wash law. If you don't wax law. But if you drive a Lamborghini, if you drive a Ferrari, you drive a Nissan GTR, then well, of course you will wax your car because it's a very nice car. You want to protect your car, right? Or you drive like a 1970 BMW. Your BMW is like 50 years old. You are like one of those old car collector. You want your car to look nice even it's 50 years old. Yeah, then maybe you wax your car. But for us, I drive a Toyota. Okay, I don't care. I mean, I wash my car once every month. It's only when my car is super dirty only I wash it. Okay, I don't really wax my car because I just don't have the time. Okay, I don't care. All right. So if you really care about your car looking shiny, then yeah, wax your car. Okay, and polish it once in a while if you don't mind the effort. Okay. So anyway, so let me summarize this. If you have a even surface, you have nice reflection, you have shiny surface. If you have uneven surface, okay, you have uneven reflection, your surface will look dull. This is why wood, they look dull. So how do you make wood shiny? You put a layer of clear coat. It's like put a layer of mirror on it. So your wood will look shiny. Okay, you understand what I mean? So this is how polishing works. Okay, anyway, so let's look at when do we use reflection? When do we use reflection? So number one is our periscope. You know what is this, right? You know what is this, right? Periscope, we use it in submarine. Okay, submarines. So periscope works by using the concept of reflection of light. So when you want to, let's say there's a wall here. Okay, let's say there's a wall here. You want to see over the wall. Now what do? You put a periscope here. Okay, so whatever that's here, they will go into your periscope. And then there's a mirror here. They will reflect your light down. And then this mirror will reflect your light back to your eyes. So you can see something lah. So this is 2 reflections. So periscope works by using the concept of reflection. So light from the sea surface is hit through the top mirror at 45 degrees and is reflected. And then the light is reflected again at the second mirror. Okay, so reflect once, reflect twice. So light is reflected right into the eye of the observer in the submarine. So this is how you see this. Okay, so that's a submarine. Your camera works the same way. Okay, your camera actually works the same way. I'm not sure you have seen a DSLR before. Do you know what's a DSLR, guys? Do you know what is a DSLR? Those professional camera, they look like this, you see? I was just teaching my Phone 5 this just now. All right, so when you use those kind of big camera, okay, so when you try to take a picture, the light will go to the mirror. Okay, there's a mirror here, and then it will reflect up. You see, this is a periscope. This is a periscope here. Your camera is a periscope, so this thing will reflect again back to your eye. So you will see whatever that's here. So if you really like what you see, you press on the shutter. What do you hear? When you press on the camera shutter, you will hear tick-tock. That tick-tock sound. What is that sound? The sound is actually this mirror moving. The mirror will go up. Can you see this arrow here? The mirror will go up. Okay, that's the tick sound. Okay, the tick sound. And then this sensor, they will capture the picture you want. And then after capturing, they will put the mirror down. The chak sound. So tick-tock. That tick-tock sound is the mirror moving up and down. Okay, so camera is actually a periscope. Okay, it's just like a tiny periscope. Okay, a small periscope. Okay, I'm talking about real camera, not your phone camera. Your phone camera has no periscope there. Okay, so you get what I mean. Next, kaleidoscope. I'm not sure whether you have seen this thing before. Kaleidoscope is basically you have like few mirrors on one end. All right, so they put like tiny papers here, okay, colorful papers here. So when they do reflection, they will reflect like 8 times. So you see that nice pattern around. So these patterns are obtained due to the repeated reflection of image. I see you repeat many reflection inside the kaleidoscope. Therefore, the number of images seen is more than the number of objects. So, I mean, nobody plays with this thing before anyway. I mean, anymore lah. That's your kaleidoscope. Are there? You see? This looks like a crazy acid trip. All right, there you see? Can you see the end there? There are all the mirrors there lah. The mirrors and the colorful paper. So when you twist it around, the pattern will change, and then you see this nice repeated pattern. That's the kaleidoscope. Okay, so because of the reflection, can you see the image is repeating one? That's the reflect. They repeat the reflections. We will see a nice pattern. All right. I mean, it's just a very simple toy lah. Nobody plays with this thing anymore. Okay, this is like our parents' era toys already. Okay, nowadays you buy a kid this thing, he will ask you, can I have my iPad instead? Okay, they don't care about this thing. All right, so that will be your periscope and kaleidoscope. So they will use reflection. So guys, learn how to draw this diagram, please. Okay, learn how to draw this diagram, please. Okay, and please learn how to draw this normal. They will ask you to draw this thing. Maybe in exam, maybe. All right, so anyway, we have like 5 minutes left. See if we can do any exercise today. Okay, I know I talk too much today lah. Okay, so let's look at question 1. Let's go to page 5. Okay, this is uploaded into Google Classroom already, so you can check it there. So let's look at page 5. So okay, this is your reflection as you can see. This is a ray of incident, ray of incident, the going in one. You see the arrow, this is going in, and this is coming out, a ray of reflection. So you have an angle here, you have an angle here. So this is the normal line. Can you see? You always draw the normal line, 90 degrees. Okay, so this is a mirror here, so they will reflect the light. So as you can see, when my incidence angle, when my angle of incidence is 20, when I go in at 20 degrees, remember, always measure from the normal line. If I go in at 20, I will come out at 20. If I go in at 40, I will come out at 40. So 40, 40. If I go in at 60, I will come out at 60. Okay, you get the point. Okay, so like I said, this is the law of reflection. Angle of incidence is always equal to the angle of reflection. Okay, really important. So A, based on the result in the table above, what is the relationship between the angle of incidence and the angle of reflection? So as I said just now, angle of incidence is the same as the angle of reflection. Okay, so whatever you go in, that's the coming out one. So both will be the same angle. All right, so B, the experiment is repeated by determining the angle of incidence at AD. So you see, this is what they ask you to draw. So AD here, right? So what will be the reflected one? Same thing lah. Same thing lah. If I come in Okay, sorry, if I go in at 80, if I go in at 80, then I will come out at 82. 80 degrees in, 80 degrees out. So this is the law of reflection. I mean, don't need to measure this thing so accurately lah, guys. This is just sketching. So as long as your this thing looks like 80, then your answer will make sense. Okay, so that's your 80 degrees, 80 degrees. So as I said here, angle of reflection, angle of incidence is always the same as angle of reflection. All right, so C, which of the following daily activities apply the concept of light reflection to solve daily problems? So number one, is this reflection? Yes, it is. Why? Because that's the safety vest. So this is why at night you wear a safety vest to look shiny, to look, this safety vest is usually like neon green in color so that people can see you, so that cars don't run into you. So this is correct. Okay, so this is your 3D glasses. 3D glasses is non-reflection. And then is this reflection? Yes, it is. All right. Any signboards they will look shiny when you shine light onto it. Right? They are supposed to do that. Any danger, any warning signboards on the road, okay, any road signs, anything, okay, any signboards on the road, they are supposed to look shiny. This is to alert you as a driver. Okay, so this is supposed to be shiny, okay, because they use some kind of special paint. Even the paint on the road is shiny too. Have you noticed this? Have you noticed this? That's why when you switch on your headlight, the lines in the middle of the road, they look shiny too. They're supposed to. Right, anyway, guys, I think I will stop here. All right, I think I will stop here. So next week, I shall, try my best to finish this chapter. So you shall receive your notes by next week, the physical copy. All right, so I wish you have a happy Tuesday. I will see you again next week. Okay, so take care. I will see you next week. Good night and bye-bye.